Welcome to How to Graph Linear Equations. This time we're going to talk about the standard form. So here I have the equation 4x plus 5y equals 40. This is not in the slope-intercept form that we went over in the previous video. So we have a little more work to do. Now, you may recall that we have some cheat codes to work with this. This is in the form ax plus by equals c, where a, b, and c are just numbers in the equation. They are called coefficients. A is the coefficient of x, b is the coefficient of y, and c we call the constant coefficient. So, in order to graph this, the easiest thing to do is to find a couple of points. Now, the easiest points to work with are x and y intercepts. To find the intercepts, we need to figure out what one variable is when the other variable equals 0. So I'm going to copy this over right here, and I'm going to do this twice because I'm going to do one version where I set x to be equal to 0, and I'm going to do another version where I set y to be equal to 0, and for each one I'm going to solve for the remaining variable. So let's solve this one. Well, 4 times 0 is just nothing, so I'm left with 5y equals 40. And now I have a situation where both sides of this equation are 5 times too big. So to get rid of times 5, I need to get y all by itself. I'm going to divide both sides by 5. And y equals 8. And that means I have a y-intercept at 0, 8. I have a point I can plot. I can go right over in here in the Desmos. You can see I've already written the equation in there, but if I were to just let Desmos plot it, that would be cheating. I'm not going to do that. We're going to work this out by finding the points. So I've got 0, 8 as a point. Now I go back to this equation, and we're going to try and figure what x is if y equals 0. So 4x plus 5 times 0 equals 40. 5 times 0 is just nothing. So I'm just left with 4x equals 40. Now both sides are 4 times too big. I want to get rid of times 4, so I'm going to divide by 4 using the inverse principle, where you use the opposite operation to cancel something out. So 4x divided by 4 is just x, and 40 divided by 4 is just 10. So I'm going to have a point where when y is 0, x is 10. That's my x-intercept. So I've got my y-intercept at 0, 8, and my x-intercept at 10, 0. So I'll plot that too. I have 2 points. I can draw a line through them. And to prove the point, I draw my line through them. On paper, you would use a ruler or straight edge or something that worked to make your line neat and tidy. So this is a first situation where finding the x and y intercepts, or y and x intercepts, since they're in order in that way, is actually fairly straightforward. They end up landing on a grid point. 10, 0 is a neat and tidy grid point. 0, 8 is a neat and tidy grid point. Sometimes they won't be as neat. I'll deal with the more complicated situations in another video. But for right now, I'd like you to try graphing this equation. 12x plus, it should say 12x plus 7y equals 84. All right. I'm going to actually do one more thing before I have you do that. The other thing I want you to consider is that we do have this cheat code. You might have noticed, you might remember that in the cheat codes that I've given you, the x-intercept is going to equal to c over a. Now c is 40 and a is 4. Now if you go back here to this point in this equation, I took 40 and I divided it by 4 and I got 10. This is my c divided by my a. In this case, c divided by a is equal to my c coefficient, which is 40, divided by my a coefficient, which is 4, and that equaled 10. So that gave me that x-intercept at 10, 0. Again, I went over here and I did 40 divided by 5. Well, if I look back here, 40 and 5, that's C and that's B. So it turned out my y-intercept equals C over B. So you can use these cheat codes. These are cheat codes based on the way the equation normally works out. It's a generalization that allows you to quickly figure things out. If you forget the cheat codes, you can always go back and do what I did here. Plug 0 in for x and solve for y, or plug 0 in for y and solve for x. But you'll get the same result. C over B is going to equal 40, which is the C coefficient, over 5, which is the A or X coefficient. So 40 over 5 is 8. So I have a y-intercept at 0, 8. Again, it's the same results I had before. But I did ask you to pause the video and go ahead and try what we just did with 12x plus 7. Y equals 84. Go ahead and try that on paper, please, not on Desmos. Try it on paper. It can be graph paper, or it can be just a roughed out graph on some lined or blank paper. Give it a try, and then come back, turn this video back on, and I'll show you the results. All right, I am back, and I assume you have unpaused me, or you might have gotten stuck and you decided you needed to work things out. So if I take this and I use what I just did, I replace x with 0, or I replace y with 0, and I work out the results. So the first place, I replaced x with 0 to figure out the y-intercept. I replace x with 0. 12 times 0 is nothing, so I'm left with 7y equals 84. I have both sides 7 times too big, so I'm going to get rid of multiplication with the inverse principle by dividing by 7. Okay, and now I end up with just y equals, well, 84 divided by 7 is 12. And if you're rusty on your multiplication tables, we can talk about that. So we now have a y-intercept of 0, 12. We can go down to the version where I replace y with 0. That's going to get me my x-intercept. So that's still 12x plus 0 now, because 7 times 0 is 0, equals 84. And we'll divide both sides by 12 to get rid of times 12. And x equals 7. So I have an x-intercept at 7, 0. Going back to my cheat codes, that equation, A equals 12, B equals 7, and C equals 84. I can use those cheat codes to work out my intercepts. So C over A will get me my x-intercept. C over A is going to be 84 divided by 12, which equals 7. And so I have that x-intercept at 7, 0, which we already worked out. C over B, which is going to be my y-intercept, is going to be the C coefficient of 84 divided by the A coefficient of 7, which is going to equal 12. So I'm going to have a y-intercept at 0, 12. All right, I go back over to Desmos. I plot those. I had an x-intercept at 7, 0. I have a y-intercept at 0, 12. I'll show those labels. I'll zoom out I'll just move the screen a little bit. And now we'll turn the graph on, and it goes right through them, which you could use a straight edge to make that happen. So you have 2 points. You can always make your line through them.